delighted with who we have here this evening. So Stephen Strong is here. Mr. Strong is president of Solar Design Associates, an engineering and architectural firm dedicated to environmentally responsive buildings and the engineering and integration of renewable energy systems that run these buildings. Over the past 4 decades, Mr. Strong has earned his firm an international reputation for the pioneering integration of renewable energy systems with environmentally responsive building design. The tandem has completed projects in the U.S., Asia, Europe, Africa, Middle East, Canada, the Caribbean, and Latin America. Net zero projects have included a multi-story commercial office building in Seattle that meets the Living Building Challenge, hailed by the New York Times as the greenest building on the planet. In the King Abdullah University of Science and Technology Center, it's the largest project to receive LEED Platinum and the first university building to be designed from the ground up to be fully solar powered. In 1999, Time magazine named Mr. Strong Environmental Hero of the Planet. So as I said opening up, we are delighted to have him. Please, let's give him a warm welcome.
Well, thank you for that, Carl. I'll have to take a cold shower. A good professor asked me to speak on net zero building design and beyond. But originally we had talked about the integration of solar. So you're going to get a bonus. In addition to net zero and energy positive, we're going to talk about building integration and also end with the next frontier. This is the theme of tonight's presentation and my career. A little background might be of interest to some of you. I was fortunate enough to come out of engineering school with a fully marketable skill set and landed a to-die-for job on the engineering team for the Alaskan Pipeline Project. And it was billed then and actually was the largest private construction effort ever undertaken, apparently. And it was interesting. I was on the team that was responsible for the remote power systems to power the 52 remote gate valve stations. This is a 2.5-story faucet valve in the pipeline that's automatically controlled such that it can staunch the flow of oil if there's a rupture or a seismic event or sabotage or whatever, so that the whole darn thing doesn't flow out into the tundra like Amory Lovins said, the world's largest chapstick. In any event, the pipeline program was exhilarating for a young engineer. But when the oil price went from $3.50 a barrel to $12.50 a barrel because of the oil embargo, and it stayed there, the boys had $9 of extra frosting on a cake that they already liked. And they started to really push everybody. And one of the things that apparently took too much time, the pipeline is made of 40-foot lengths of very heavy steel pipe, 4 foot in diameter. Those links have to be welded very precisely because when you come down from the mountains 5,000 feet into the valley, there's one hell of a lot of hydrostatic pressure at the base. The boys had to very scientifically X-ray inside and out every weld to be sure it was perfect. And that took a lot of time. So to push things along, they started to falsify the X-rays. They took the old ones out, they turned them around to turn them upside down, put them in the new file, the inspector came in, it's cool, keep going. Just about that same time, the engineers, scientists, and researchers that had perfected solar electricity for space-based power systems had agreed months before to come together at the auspices of Bell Labs in Cherry Hill, New Jersey, to begin the conversation of how this life-affirming technology could be used for terrestrial applications. My wife still rolls her eyes when I say that I fell in love with the concept of solar electricity after being on the oil pipeline. Now think of it. There's a slice of silicon about the thickness of your fingernail that is 99% quartzite, second most abundant element on Earth, which is essentially beach sand that gets refined. With little pixie dust thrown in, it produces electricity directly from sunlight with no moving parts, no waste of byproducts, no consumption of resources, no noise, no depletion of materials, essentially forever, so long as it's exposed to sunlight and not damaged. Oil, gas, solar. It was a tough choice, but I resigned at the die-for job. They threw money at us like crazy. Came back to Boston with a lot of enthusiasm, a little bit of money, and not knowing any better. Started Solar Design Associates and also enrolled in architecture school. My parents were tough. My father passed away when I was in high school, and so we didn't have a whole lot of money. I was fortunate to have an engineering scholarship, a partial one, and I worked through college. But coming back from Alaska, I had a bunch of money, and I decided to enroll in architecture school. Not a fancy, wonderful one, but one that I could afford, the Boston Architectural Center, which is now the Boston Architectural College. I studied there, subsequently joined the faculty, started the Sustainable Design program, and that's where we start. Things are progressing, but they're also getting worse as far as climate change is concerned. But when I started, this was a state-of-the-art solar house in the 70s. It's not going to get on the cover of any of the design journals for sure, but you have to admire the folks that are wanting to just get it done. Solar thermal, solar electricity, probably decent insulation. It's a good start. Photovoltaics was still in the research laboratory when I got underway at Solar Design, and so we started with solar thermal. You see on your left a group of condominiums in ski country with a steep roof, which was perfect for wintertime solar gain. Sun is nearly direct normal to the plane of the array. And then also larger scale. This is one of the largest solar water heating systems in New England at the time. It's about 80% of the solar hot water supply for some 200 plus moderate income housing units. Very quickly, we got in the front of the line, and when President Carter encouraged the Department of Energy to push solar electricity along, we were right in the front of the line and put in a proposal to design and construct the world's first single residence to be occupied that would make all the energy it needed and export a surplus of kilowatt hours to what would later become net metering, essentially putting power back into the grid. This house got worldwide attention, and we were off and running. Now, it may surprise you, especially architecture students, that the majority of living units on the planet are already net zero, at least historically. And it's actually not that hard to get back to net zero. These were some of the early efforts. This was a house a friend did, basically pretty straightforward, but we did the energy systems for them. It's a relatively forgiving climate in Oregon, and that's a net zero house. This is one that we designed. It's earth sheltered, super insulated, internal thermal mass, lots of passive gain, sun controlling geometry, air-to-air heat exchanger with heat recovery ventilation, fairly sizable amount of thermal storage, radiant heat distribution, et cetera, et cetera. Moving forward, after the Carlisle house, of course, people got interested in solar electricity, and we were invited, commissioned as it were, to design a house that would be representative of trends in technology and design that would be commonplace 20 years into the future. The house was named the Impact 2000 House, And after word got out, PBS approached us and said, hey, this sounds like a really cool idea. Could we do a national TV series to chronicle your design and construction and et cetera? And they did. Relevance to our conversation and Carl's initial request is, this is all building integrated. We started from the beginning, recognizing that the 16-inch by 32-inch sort of really early solar modules were really not ideally suited for building use. And we cajoled with the promise of a nationwide TV series behind us or forward with us. We got one company to make really decent size 4x6 modules. We installed them ourselves, of course, because nobody was up for that. You ask them to bid, they say, on what, for who, and how, when? It's fully building integrated. The portion in the center is solar water heating. This is actually deep space daylighting. This is solar electricity, geothermal, of course, super insulation, monolithic air and moisture barriers, internal thermal mass, radiant heat distribution, lots of passive gain, modest amounts of glass on the east, west, and north. Earth sheltering, there's a 2-story south facade and a single-story entry from the north, and on and on. Most of those principles you understand. They actually did a piece. It was called How You'll Live in 2012, and I think we nailed it. Except they're not integrating. They're just throwing the stuff on the roof. I also was asked to write a book on the subject, and I did. It was painful. Don't ever try it unless you're really committed. I thought it would take me 6 months. It took me 2.5 years to publish it. Threatened to basically quit the deal, and that's the only way it got done. Because I was way interested in designing stuff, and writing was painful. After the Impact 2000 house and the nationwide TV series, another utility project. This one was the world's first solar-powered neighborhood. And believe it or not, it was sponsored by National Grid's predecessor, New England Electric, which services a lot of Massachusetts, including, I believe, the UMass campus. And we were given carte blanche. We could go with a developer and develop something new, or we could find an existing neighborhood and retrofit it. And even then, I thought the existing neighborhood would be a lot better of an opportunity because we've got to address the existing housing stock if we're ever going to get there. And so we chose a neighborhood of basic ranch houses. Why? Because that's the highest or lowest or most common denominator of housing stock in the US. In the Southwest, they've got Spanish tiles, but pretty much the same building. And so we basically retrofitted as many as we could, including the city hall, the library, the community college, and what else? A furniture retailer in town. This is in Gardner, Massachusetts. About the same time, Georgetown University decided to build a new intercultural center, and we elbowed our way in because, well, there wasn't anybody else doing this stuff anyway. And this was the first large-scale commercial building to be designed to receive solar electricity. It looks building integrated, and you could say it's integrated design-wise, but when I speak of integration, I'm talking about the solar serving as a building material, displacing conventional materials, and in many cases becoming the finished weathering skin. This is an example of a house I designed on the Maine coast. You see the solar thermal is here. You see a slight difference in the color of the texture of the roof. That's photovoltaics. Both technologies combine to form a single uniform glass plane that makes up the weathering skin of the structure. You see, if you're paying attention, there's an asymmetrical ridge. That is a large free surface area of ventilation. The soffits are all perforated, and the solar modules are cooled from underneath. The incoming air for the air-to-air heat exchanger in the winter is pulled from under the array up here. and that gives me about a 20-degree bump above ambient on a sunny day, which is not bad. In the summer, the input is in the north side down in the shadows. Again, super insulation, internal thermal mass, radiant heat distribution, air-to-air heat exchanger with heat recovery ventilation, radiant heat distribution, R10 glazing, R40 walls, R65 roof, I think, or so. Very good air sealing, etc. What do we got? Oh, yeah. You'll see how, first of all, lots of passive gain. Can anybody tell me how the site contouring and landscaping becomes part of the heating system? Come on, professors here. Speak up, not Morgan. Well, come on. What is it?
Reflection.
Yes! It's sloped down to the south and southeast. Nice, fresh, gleaming white snow in the morning, and the house pops up with about 2x sun. And then, of course, the sun conveniently moves off axis, so it doesn't grossly overheat. But when you have a freshly falling snow and a lot of good sun, I want you to notice what happens here in the middle of January in Maine. The windows are open because they have surplus heat. Going up in scale a bit, we were privileged to be involved with the first solar-powered Olympic Games. This was at Georgia Institute of Technology's campus, the women's and men's swimming and diving venue, which was open air during the summer games, but was designed from the beginning to become the new athletic center. The large array in blue is photovoltaics, of course. The two black strips on either end are thermal panels, which were put in place, of course, to keep the pools at proper temperature. Stepping up into more sophisticated building integration, another university project. This was the new School of Business facility at the University of Oregon in Eugene. The architects, the principal was an alum of the University of Oregon and wanted to create a monumental building that exuded solar. The roof is covered with solar, but of course you can't see it. It's very productive up there. And so they said, well, what about we could somehow put the solar cells somehow in the facade, maybe? It's like, yeah. So you're buying the glass already. You're buying the aluminum already. If you do a little bit of engineering, you can get UL listing for running the conductors through the aluminum curtain wall because, of course, they're hollow. And the architects wanted to be able to have a high level of visibility at the ground level where everyone was, but in the open atrium, we packaged the cells much denser above to keep the sun out in the summer and maintain reasonable temperature, while, of course, showing off the technology. We were privileged to be involved in New York City's first solar high-rise. This was about that same time, working with Caesar Pelli and Associates. In this case, the solar modules are part of the weathering skin, just at University of Oregon. However, they are part of the opaque facade. There's also a custom bifacial solar cell entry canopy at the street entrance to show off the technology, and the equipment screen on the roof is wrapped with solar. Back to residential scale, this is a house I designed in North Carolina. You see a larger solar electric array here because they are in air conditioning zone. The top is, of course, solar thermal. Again, the two technologies combined to form a single uniform glass plane that makes up the entire south roof and is the roof. Nowadays, the lower cost version is you put the modules on, and then when the roof fails, you take them off and you replace the asphalt shingles. Not a good idea. Who's paying attention? What's wrong with this picture? What was that? You think? This is a perfect example of disintegrated design process, where the architect and the site planners and the landscape architects were just not, and first of all, this is in Southern California. That stuff should have been on the roof. You know, the sun is really high in the sky the further south you go. So it really frosts my hindquarters when you find out that you got the LEED Gold, they got AIA Top 10 Environmental Award, and some other accolades, and it's like, oh, come on. No. A little bit more on the integration side. This is an entry canopy that the clients, this is the MITRE Center in Bedford, Mass. They were going to have an entry canopy along this promenade from the parking area into the building, and they wanted to show off the technology. There's solar, again, all over the roof, but you can't see it. And so we developed these custom structural glazing units with bifacial cells, which take advantage of the ground reflection, and of course are really neat to look at, which I like. The thing is slightly butterflied. The water falls into a central gutter and is drained away so nothing drips on anybody. And we got sort of sidetracked and a little bit impatient with the major auto manufacturers, so we decided to hack one of our Gen 2 Priuses and make it all electric. And yeah, don't do that at home. And our clients, of course, the house clients occasionally often will drive a Prius, and they said, oh, wow, that's really cool. Could you make one for us? And it's like, no. I don't want to hear from somebody in a pouring rainstorm on the side of the road on the Mass Turnpike on Sunday night saying, the red light's on. But it was fun. The biggest benefit for solar power is not on the building across the street, but in the third world, the developing countries, because they don't have a significant grid infrastructure. It's like the wireless phone took over in all the developing countries. There's no phone lines. They don't exist for the most part. So solar is happening all around the world and is especially appropriate in developing countries. This is the first solar system on the White House. I was privileged to be on the roof with President Carter when he dedicated it. And I was inspired as a young engineer, as you might imagine, supremely inspired. And then, not much longer forward into the future, the next tenant of the White House removed the solar modules and confined them to the dumpster. Somebody in the government surplus properties department thought better of that and put them up for auction, and they ended up at Unity College in Maine and provided the domestic hot water for their dining hall for another 2 decades. I was incensed by the fact that Reagan would tear them off for no reason. They said, oh, it's necessary for maintenance. Well, that was BS. So I made it a career goal, always sort of in the background, to get solar back on the White House. It took me 20 years. And during the early 2000s, I would frequently be giving a lecture like this at the AIA convention or USGBC or the ASHRAE or whatever, professionals or students. Students were most interested, professionals were still skeptical. And after a half a day or a day, people come up afterwards and they ask questions. Somebody was standing in the back waiting. After everybody finished, come up and I don't see that well, so I could finally read his badge. So-and-so AIA, National Park Service, said, hi, I'm so-and-so. The beginning of next year, this was in November, I'm going to be the White House architect. The White House has a full professional team of architects, electrical engineers, mechanical engineers, et cetera, so if the air conditioner fails and the state dinner's in 2 hours, they've got the SWAT team there. This was the architect that was going to manage all of it. And he said, I'm convinced we need to have solar back on the White House. And I said, yes! And he said, I take office January 1. By the time I get settled, we're going to call you, come down in February, and we'll figure out how to do this. We did. Secret Service owns all the roofs. They have all sorts of conditions and et cetera, but we found 3 locations, had an agreement, signed a 1-page agreement, And in August, we came in like a SWAT team and installed 3 solar systems in 1 week while W was off at the ranch cutting brush. And we're carrying the thermal collectors across the front of the yard. And by the way, I made one of them fully roof integrated, so if they removed it, there'd be a big hole in the roof. Lots of fun. A tower designed by Hugh Stubbins in the 70s was perfectly configured purposely to take a large solar array. It's the Citicorp Tower in Midtown Manhattan. The Citicorp folks wisely decided to defer the solar because Mr. Stubbins was a visionary, but the technology wasn't ready for that scale and application, and so it sat. During the interim, from mid-70s through the early mid-2000s, we had 3 requests when the tower changed hands. Hey, can you put solar there? The latest was with Boston Properties. Boston Properties is one of the most successful real estate investment trusts, and they wanted to sort of take a victory lap in New York. And the challenges are severe here. There's a wind loading, especially uplift from the north. When the wind sweeps around behind, there's a huge uplift. We had a lot of ciphering for that. And then they found out how much it cost and said, oh, well, we're going to think about it. Here's another quiz for you. What's wrong with this picture? Come on, this was easy. Shading? Yeah, you think? I mean, duh. Now, this is what happens when you take low bid. This is a solar thermal system, and the piping run to the equipment room was the easiest straight down on the west side of the roof, so that's where they put it. Getting into building integration and transitioning into net zero. This is a project we did with Chris Williams. Chris Williams, our local architect up in New Hampshire, the Tin Mountain Conservation Center. This is it's sort of like a summer study for students that want to get introduced to the environment, wildlife, eco-cycles, and that sort of thing. Really cool. They have a staff of PhDs in various disciplines that volunteer or get a modest stipend for the summer to deal with the kids. Again, full roof integration. This is solar thermal here. That's solar electricity and solar electricity. And just for fun, I'll share because Professor Carl thought it would be good to get an understanding of the challenges with net zero design. And in this case, the owner education and accommodation, permitting, and contractor selection and education. One of the biggest bones to pick I had with the design team and the client was this. It's a beautiful traditional stone fireplace. To me, it's a glaring energy nosebleed. The damper is typically left open, and the stone often goes right through the exterior envelope. And when you come in, if the heat's been sent back at night, you've got frost on your mantle. So, and the mason was an old school mason, and my goodness, did he not want to hear from me. But anyway, what we did is we split the masonry so that inside is absolutely glorious, which is what they wanted. But there's an insulation layer, a thermal bridge, if you will, a break, I'm sorry, made of what's called structural foam glass insulation. They use it in refractory applications. And they have a top-of-chimney damper as well, so they've got 2 dampers and radiant heat distribution, internal thermal mass, in addition to the fireplace stone. R10 glazing, air-to-air heat exchanger, biomass boiler up here, as you can see. So they have no fossil fuel on site and produce a surplus of electricity. Stepping up, the first college academic center we did, which was to be net zero. This was the new Environmental Studies Center for Dr. David Orr, who was then chair of the Environmental Studies Department out at Oberlin College. And he worked very tirelessly to raise some money and went to his administration and said, here's my plan, here's the money. When do we get started? We would like to have this parcel of land. And he was very persuasive, and they got underway. The challenges for the first Net Zero Academic Center were, obviously, as you might think, this was the architect's first net zero project. And unfortunately, the architect had an ego that was larger than the room we would meet in, and was unable to collaborate or even just not willing to collaborate. Defining and maintaining the project budget was a challenge. The lack of solar aperture that was offered was really a deal killer. A lack of whole system thinking was prevalent through the whole process because the high highness architect would not even collaborate with the consultants they hired. Defining and maintaining the energy budget was almost impossible because there were 3 mechanical engineers that couldn't work with the architect and resigned in succession, and so you can imagine following that along. And then what else? Contractor selection and oversight, utility policy, and permitting. So let's look at some whole systems thinking. This is the roof that we got. And the first time I saw the drawings, I said, that doesn't work. We need a sloped roof. You need to keep all the modules in the same plane. If they're curved, they don't perform. It's like a sled dog team with huskies, poodles, dachshunds, chihuahuas, and German shepherds. The less illuminated modules serve as a resistor in a series circuit and drag down the whole roof. In addition, 40% of that roof is not even sunlit in the fall, winter, and spring when you need the electricity the most. But the architect would not hear of it because we didn't understand design. We put the highest efficiency solar modules on the roof that were available then. These were special monocrystalline cells that were laser etched and all kinds of things to push the envelope at the time. But, also, it was to be geothermal. But the site plan left this little postage stamp for the geothermal wells. First time I saw it, I said, those things are going to step on each other, and at peak periods, they're not going to be able to pull as much BTUs as you need. You've got to spread these out. No, that's the site plan. That's what we have. You don't understand. There's something, and there's other things, and there's going to be an orchard over here, and that's what it is. So shut up. Well, you notice I had a tough time on this one, but you got to see this. You do really need to see this. The gray is the HVAC, which is basically the geothermal system, which should be down here somewhere. And then when it gets really cold, it just blows the whole budget for the year, just for a day, a single day. And so I sent this cartoon to the architect. Needless to say, we never worked again, but that was a good thing. David Orr was very disappointed and discouraged, but not dissuaded. He was going to push ahead anyway. But here's another example of whole systems thinking, which I think is absolutely critical. Collaboration is absolutely critical. A uniform design team that basically everyone has a say. Yes, the architect should be leading the process, but not in the traditional manner. The whole idea for this project was to throw everything in here. It was like a sandwich with everything on it. And one thing that Dr. Orr was encouraged about was this living machine, where the waste from the building would be processed on site and then basically put out into this constructed wetland. Very nice idea. The architect designed an excellent sort of garden house. One issue, though, was there wasn't any collaboration with the living machine engineer or scientist. And there was more room that was needed. And the architect said, well, look, we've got to have this full. We've got to fill it. I designed this space. So obviously they got more material, more beds in there. But what happened was the living machine was oversized for the load from the building. And when students went on spring break, they came back to a system that had crashed and had to have a poop campaign to restart the living machine. And of course, I sent copies of this to the architect. Now remember, we had very low solar electricity compared to the building's demand, but this was an untapped solar resource. Dr. Orr was not going to take no for an answer. We couldn't rip the building apart. And so he said, well, look, you guys are the solar people. Let's just add some more solar. What can we do? We designed a long span space frame truss, covered the parking lot adjacent. And here's what we had when we finished. There's what we had before. This is what we had now. And you see that we're actually net positive. And there's the result. The rest is shared, of course, with the campus. And that's what the Oberlin project looks like. And there's Dr. Orr. Pushing the envelope, of course, especially if with new technology, is exhilarating. Our happy, smiling clients, like the ad, are priceless. And it was an absolute privilege to work with Dr. Orr. He was always smiling. He was never deterred. You know, you'd have a whole total shitstorm, and it'd be, don't worry about it. We'll work it out. Just you know, let's keep the course here. The first college academic laboratory to be net zero. We were privileged to be on the design team with DeMille Schaefer, a Boston architecture firm. This was promoted by Governor Patrick when he was in office. The building was already in process. It was through schematic design, and the governor said, guess what? We're going to make this net zero. Okay. Well, here's the issues with that. Architect's first net zero project, although these folks were willing to be, in fact, anxious to be collaborative, they wanted to learn. They wanted to know this stuff. They wanted to replicate and move it forward. The project was already underway. The design team was not selected for net zero. They didn't have a mechanical engineer that had anything to do with energy modeling, because why would you model energy? Well, they got an energy modeling firm that had done this a few times. And by the way, the most important thing about a net zero building is don't start with a team that hasn't done it, regardless of how eager they are, because this is going to be a long haul. You've got to see somebody that has done this before and succeeded. Defining and maintaining the energy budget, again, contractor selection, commissioning. Oh, yeah. There was no money in the budget to commission the solar system. So they had the commissioner that balances the airflow and the ductwork. Well, you just add that to it was a total mess. We had to come back and commission it anyway. Utility policy was a challenge, and permitting was a challenge as well. Also, we didn't have enough room on this space frame truss that we designed to sit on the roof. We get a bit more performance out of canting the solar, but it was still not enough because the energy model kept getting bumped up as it went along, of course. And so we ended up going out into the parking lot with these solar canopies, but that was cool. I said, yeah, we can do that. The first government agency to be energy positive, this is the Fisheries and Wildlife Field Headquarters in Westboro, Mass. Finally, an architect that, you know, we were right there. Architectura, they're all about net zero. In fact, they don't want to do anything else if they can help it. So we got just an amazing building here. Energy positive. Designed perfectly to receive the solar, optimum orientation, optimum angle for annual maximum harvest, very good envelope, good daylighting, et cetera, et cetera. I mean, just there. The net zero and energy positive buildings are even in communities, are here and within reach. All it takes now is vision and commitment. And new construction is obviously easier, but retrofits are being accomplished. They're known in many cases as deep energy retrofits. The simple net zero formula is energy supply minus energy demand has to be greater than zero on an annual basis. And the success formula is efficiency, efficiency, more efficiency, still more efficiency, conservation, and then owner and occupant commitment, and then renewables. The way I get everybody's attention, we sit down. I'm a solar guy, but solar's the last thing I want you to do. What? Yeah, really. Like, you know, if your building is an energy nosebleed, I can't power it with solar because you need 3 or 4 roofs. So, efficiency, 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 efficiency. Professor Fiocchi knows all about building science. Take his courses, learn this stuff. Even if you don't want to build net zero or energy positive buildings, just make them decent at least. A project we just finished recently for Clark University. This was also with Architera, another privilege and a pleasure to work with those folks. And they wanted to basically dress this up a bit, so we integrated a picture frame ribbon of frosted glass around the perimeter and lifted the array above the mechanicals on the roof so we could get the full footprint. And interesting thing, of course, we finished our construction documents, signed and sealed, sent them off, and I don't know, a month later, 3 or 4 weeks later, got a call. This is the general contractor. We can't make much sense out of this, and we can't get anybody to bid on it that we have any faith in. Can you build it for us? All right. We do take on construction projects. I have a general contractor's license as well. When nobody else will do it. Or maybe we consult because we really want to get it done right. This is a house I designed not too long ago in northern New England. It is energy positive, and the normal passive solar, super insulation, internal thermal mass, R10 glazing, active solar thermal for space and water heating, generous amount of water storage for the thermal, radiant heat distribution, whole house HRV, and of course electric vehicle recharging. This house provides all the energy it needs with a surplus and powers the owner's transportation on and off site. Closer to home, the Thoreau Memorial Visitor Center was recently completed at Walden Pond. We had the privilege of working with Mary Ann Thompson Architects, a Boston architecture firm, also very focused on energy efficiency and net zero. They don't want to cut the lawn at Walden, never mind cut any more trees. So it was a foregone conclusion that the solar to power the facility would be in the parking lot, which was, already cleared. You'll notice there's some green parking spaces. We added electric vehicle recharge ports in the parking area, some under the solar canopies, some closer to the visitor center. And one additional passion beyond solar electricity, which is perfect hand in hand, is electric transportation, of course, solar-powered electric transportation. It's absolutely awesome to run on sunshine. My son and I both have Zero electric motorcycles. Mine is just a regular one, which is 0 to 60 in 4.6, I think. His is the scary fast one, 0 to 60 in 3.9. Or is it 2.9? It's way scary fast for me. But the big boys with the heavy iron, when they start them up, the earth rumbles and shakes. They think it's a girly machine because it doesn't make any noise. They're in my rearview mirror like that. And I know it's geeky. My wife would roll her eyes. There's nothing more awesome than running on sunlight. Really, there isn't. So at the dedication, they had this famous person come. Can anybody guess who that is? Probably not. You'd never, ever expect to see this person in a suit and tie. But when you have a dedication for a new building, the client is very gracious and thanks everybody. Thanks the architects, thanks the engineers, thanks the solar consultants. And by the way, he said, Stephen Strong and his son brought their electric motorcycles and they're charging under the solar canopy. And the keynote speaker, you might be able to recognize him here. Who's that? Don Henley, yes.
No way.
Yeah. Yeah, you wanted an electric motorcycle? Does my helmet fit? Sure. Take it out, Don. Take it easy, Don. I'm going to put it on eco mode and, maybe just around the parking lot, would you? Yeah. So I think you bought one. Community solar is a really important focus. Why? Because when you do the numbers and consider all the opportunities or lack thereof, 60 or 70% of the people who have a utility account can't go solar even if they want to. They're in an apartment, they're in a condominium, their house is in a pine grove on the north side of a mountain, they're renting, whatever. And so we decided to do community solar and constructed what is, I think, the first and maybe only shareholder-owned solar garden. It's a 0.5 megawatt of solar directly across the street from our offices in Harvard. We take care of it, and our office is powered with solar, and our vehicles are powered, charged with solar. And it's really cool. There's no profit maker in there. It's just the subscribers, the shareholders. And whatever size you subscribe, you get the benefits. And because we got in early with the SRECs were really high, this is just awesome. Another project for university. This is one of the few wind-powered campuses that I know of. It may well be the only one. It's the Massachusetts Maritime Academy at the western mouth of the Cape Cod Canal, right at the head of Buzzards Bay. The provost is, in this case, a commandant because it's a maritime institute. And some wind folks came in and tried to give him the sales job. And they sat down, he had him in, and they started to pitch him on 2 years of data acquisition with a Met Tower on campus and all this data logging and data reduction and analysis and everything to tell him how much wind capacity he had. He said, well, boys, did you notice the flag when you came in here? I said, no, sir, I didn't. Well, I notice the flag every day, former military guy. And he said, it's out like this every day. I know which way the wind's blowing. I don't need you folks. Thanks for coming in. And we did the wind turbine. This is a campus scale wind turbine. It's actually one of the earlier utility scale turbines. And fortunately, this campus, like perhaps parts of UMass here, the campus owns the distribution network and there's a medium voltage substation connection. So this turbine feeds all of the buildings on campus before any electrons leave. If you're going to Cape Cod and you go across the Bourne Bridge, you can look to the west and you'll see it spinning around very nicely. Here's the building that Professor Fiocchi mentioned, the Bullit Center, the world's first energy positive multi-story office building, also just incidentally qualified for the Living Building Challenge. You might see that the array is a bit outsized for the building's footprint. When you get into the city, of course, you've got very tight zoning. And the first day, I sat down with the design team, looked at it and said, sorry, this isn't going to work. We can't help you. Why? There's not enough aperture. Well, you're the solar guy. Figure it out. I mean, come on. This was Dennis Hayes. Dennis Hayes is now the head of the Bullit Foundation. He was the founder of Earth Day, as you may remember, some of you older folks, and also head of Western Sun and at the Solar Energy Research Institute in Golden, Colorado, until Reagan pulled the rug out from underneath that anyway. Very heavily committed to renewables. So I said, well, you're going to need at least twice the aperture. There was a woman sitting at the table, and she was there because there was a very interesting, friendly, or perhaps not so friendly competition between Seattle, Washington, and Portland, Oregon, as to which city could be the greenest one. And she happened to be the chair of the Planning Commission. And she was all in on this. And so I did a sketch, and I said, you know your college graduation hat? Well, that's basically what we need here on this building. And she said, that's going to be out over the air rights of the public way, and that's going to be a problem. And Dennis said, I know you can solve this. And they had a little chat, and I didn't hear anything, or a week, 2 weeks, 3 weeks, I got a call, Stephen, I've got an answer. She had an answer. She's the chair of the Planning Commission. Well, we're going to call it an awning, because the commercial code in Seattle says that commercial buildings can have awnings. And no one had defined what an awning was, and she's the chair of the Planning Commission. She just defined what an awning was, and that was it. If that didn't happen, this project would never have succeeded. Geothermal heat pumps, the wells are underneath the footprint of the building because that was the only real estate that was available. Because they will interfere with one another or step on each other in terms of their cone of influence, they have to be very deep. They're 700 feet deep. There's a whole bunch of them. And of course, you can't get at them because they're under the building. And so you better darn well be sure everything's done right before you pour the slabs. But that was good. They really had the best contractors they could possibly find. They interviewed the heck out of them. And of course, they had to have the experience and et cetera. World-class building. Living Building Challenge is not simple. It's an order of magnitude more challenging than LEED Platinum. LEED Platinum, up until recently, as I understood, never even had any metrics. You just sent in your checklist and they gave you this plaque, the gold plaque you put in the building, in the foyer somewhere. Living Building Challenge, they don't give you anything until you have a year, the first year of solid data, and they check the accuracy of your data acquisition. This is a delightful building. It's sunlit. It is just, it's a wonderful place to work. Radiant heat, virtually no cooling is needed. They have ventilation. The windows open and close themselves to provide just the ventilation that's needed for air change and, more importantly, to cool the building at night when it's not occupied and the mass gets chilled down, and then they close them in the daytime. This is the first public building, multi-story building, to have composting toilets. Believe it or not. It's also the first building anywhere, I think, that has a state-licensed public water treatment system, because the Living Building Challenge will not allow you to connect to any city services except the utility. And in this case, they make an exception. Well, of course, we're exporting. So this is the water system, net positive water. The array has spaces between the modules. The water flows onto the roof. There's a water purification system here, and that's what's being used. The gray water is recycled, etc. And it's the first building I've ever seen where the mechanical spaces and equipment room are being shown off. They happen to have a park. This is a West Pocket triangular-shaped park. There's 2 streets converged. And the city was bending over backwards to help this project succeed. And they said, you know, we're really sorry, and we apologize that we haven't been keeping the park up. You know, the budget issues, and there are much higher priorities. So you can have it if you agree to keep it up. Now, it'll still stay in the city's name because changing the deeds and all of that would be, you know, you don't even want to start there. But we're telling you, it's your park. And by the way, we will take the street that runs immediately in front of the door and separates the building from the park out of public use. It'll be open with pavers for emergency vehicles should they have to travel through, but it's yours. So now they have this wonderful esplanade in front of the building and then the park. Here's a bit of construction process. Fortunately, I didn't have to check the steel. That was somebody with a lot more courage than I have. You know about, well, this is a good lesson here. This is what's considered a reasonably efficient at 72. I'm sorry, an average building, but Energy Star code, Seattle code building is 50, so 72. But existing office buildings are well over 100. Never mind what the units are; it doesn't matter. 51 is a Seattle Energy Code.
They know the units.
They know the units.
They know the units.
What are they?
Okay, BTU per square foot per year.
Okay. Thank you. All right, so LEED Platinum, if you take all the energy credits, is 32, and the PV budget was 16. The proposed building was 16. And just graphically, this is the array in true size and shape and scale. If we had designed to typical office building requirements, this would have been the size of the array, which is a city block. If we went to the next EUI of 52, we would have had this size of array. If we went to LEED Platinum with all the energy credits, we would have had essentially 2.5 times the size of an array, which was already oversized for the footprint of the building. So again, efficiency, 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 more efficiency, conservation, owner-occupant buy-in, then renewables. Because that's what we did. And of course, that's expensive to cover the entire block of it. You know, a lot of permitting and stuff on other people's buildings and things. I'm going to skip this because I don't have an audio plug-in. But again, pushing the envelope, it's exhilarating. Happy, smiling clients. That's Dennis. And net zero success formula. Fully qualify the client. Does the client know what they're getting into or getting in for? And fully qualify the site. Does the site have the resources available to get there? And then, darn it, retain the right architect. Build a winning design team that's collaborative. Nail the energy model. That is the biggest, hardest challenge. It's just like throwing darts. The people that are doing these energy models are really clever. They've got a whole lot more on me. I mean, the solar equation is simple in comparison. We've got to have a target. We've got to have a target to start before the building's designed, not after it's designed, not after it's in service. Before it's designed, as it's in schematics. And that energy model is refined and may go up, may go down, but it's a work in progress. And it is absolutely the holy grail. If you don't have the energy model, forget it. It's like blindfold on. How do you get there? What's the target? And of course, hire the right contractors. A little bit of inspiration. The solar impulse was flown to circumnavigate the globe. And the Planet Solar trimaran circumnavigated the globe. This is solely, completely on solar power. Lots of fun. I got to tour this. It's just absolutely awesome. Funded in part by the same Swiss industrialist that did very well at what he was doing and wanted to do something really cool. Professor Carl mentioned the King Abdullah University of Science and Technology. Boy, we were way out of our league on this one. We got a phone call from HOK, which at the time was probably one of the top 2 or 3 design firms in the world, saying, we've just gotten a commission. It's got to be solar powered. 6 million square feet of first-class academic space and research laboratories from first conversation to full occupancy in 3 years. Can you help us? This was like college exam week for about 6 months for us. We're only 15 people. It's just like, bring a sleeping bag. House schools, 6 million square feet of world-class 3-year schedule. When the king announced the project, he also announced the day he was going to dedicate it. Yeah, very interesting. Climate responsive design greatly exceed LEED Platinum, very aggressive energy efficiency, solar powered, net zero, beyond state-of-the-art technology, very smart grid, and the king's legacy. And this is not your junior college. This is awesome. I mean, and the laboratories. This is a research facility too. State-of-the-art, fully instrumented, fully outfitted laboratories in every single discipline. And what's the focus? The focus is on, believe it or not, alternatives to conventional farming, hydroponics and aquaponics and soil sciences, and upcycling and mining landfills. They're looking way over the horizon. And by the way, what they're doing with their oil revenue, they're building renewables by the gigawatt, because they know better than anybody when their reserves are going to be drawn down. So basically, we had carte blanche to cover everything we could with solar, and there's also ground-mounted to be certain that everything was covered. One of the biggest challenges in the desert, can anybody guess what that might be? What is it? Yes. This sand is not like the beach sand you crinkle between your toes at the beach. This is like baby's talcum powder. And it stays on everything almost like with an electrostatic cling. And so cleaning the arrays was a big challenge. To have fully outfitted greenhouses on campus for the advanced agricultural sciences, water purification, all of the stuff that used to be 20 years ago on Mother Earth's news front page, front cover. Challenges: sheer magnitude of the project, extreme fast-track schedule, defining the energy requirements, an international design team. We would get drawings that were like this. Establishing codes and standards. Whose codes are we working from? We've got US-based, we've got European-based, we've got Asian-based, we've got, yeah, lots of fun. Collaboration. Who's going to call a conference call time? Who has to get up at 3 a.m.? And this was just multiple languages. It was really something. Really something. So the king's mission, when he dedicated the building, he said, "This is dedicated to post-petroleum sciences." Can you believe that? Another project we're working on in the Middle East, this is with Perkins and Will. It's the gateway to Mecca. It sounds very grandiose, but some of you may have heard that millions of people come to the Hajj, the religious pilgrimage, each year. And the crowds are so intense at getting to where they need to go that lots of people have been trampled, actually, because of crowd management and all of that. So this is the gateway to Mecca. It's a multimode, multi-tier transportation hub. There's buses and intercity trains and long-distance trains and local, all the transportation comes together. And the architects were very clever about this. They created this giant sunshade under which they built the building. And the louvers are such that the wind can go through the building and cool it, but the sun can't get in. And of course, what did we do? We covered all of those curved louvers with solar. The Middle East is going all in for solar. That's They're doing it. Australia's doing the same thing, by the way. They're still selling nasty, dirty, big, black, beautiful coal to the the Southeast Asian market. And their foreign exchange is going into, guess what, renewables. And hopefully they'll run out of selling coal soon. Another project that we worked on in the Middle East, this was awesome. This is the new headquarters for the Dubai Water and Electricity Authority. It's a quasi-government agency, as you can imagine, and it was meant to be at least net zero, if not energy positive. We were brought in by the International Architecture Consortium, which is a bunch of groups, to basically help them figure out whether this could be done in a very, very unforgiving, scorching hot climate. The model basically shows that the canopy fully covers the building so that it's in shadow all the time. And of course it lets air move through, just similar to the gateway at Mecca. We also worked on their National Solar Innovation Center and helped them with the planning of their first 200 megawatts of a full gigawatt of solar in the desert, which where we really found out about the dust. I'm sorry. Wrapping this up, the next frontier is solar plus storage. This is just a list of the way to monetize on-site storage, whether that is on the customer side of the meter or possibly on the utility side of the meter. We'll talk about that. One of our first solar plus storage projects was back in the 70s. This is what we call a house on the rocks. It's in Narragansett Bay, Narragansett Harbor, Rhode Island. There's a big bunch of ocean that goes from up to Providence, and lots of water, lots of rocks. And this house was built by an industrialist in the early 1900s, sort of as an alternative to the very proper, prim, garden manicured mansions on the ocean's front in Newport. He wanted something a little different. It had a cable from the mainland, but that had failed long ago, and the building was left vacant for many years. It was purchased by a couple. He and she were both architects, and they thought they would revitalize the building and could not see putting another cable in. It was very expensive. So they run it. It's basically a 2.5 season, or late spring to middle fall, and it's shut down in the winter. That's what it looks like. And it's very modest. They had a very robust masonry core in the center of the building, which was able to take a residential scale wind turbine. There's solar thermal, there's PV, there's modest amounts of loads, there's no climate conditioning, modest amounts of light, and basically just refrigeration and water pumping. The system diagram shows the wind turbine and the solar array, battery storage, inverter for AC loads, and they do have some DC loads. A lot of the lights are DC because they wanted to be, or we wanted to be, very thrifty with our kilowatt hours. And of course the inverter has 8% or so tear loss going through. Challenges here: logistics, salt environment, lightning protection, of course, you think. Guest conservation compliance, of course. They had more friends than they ever knew in the summertime. And they'd bring the 1,500 watt hair dryers, and 2 of them, by the way, so they could get dried off quicker. So that was interesting. The next one is batshit crazy. Absolutely the craziest thing. But one day I came home and there's this tall, dark, and handsome, strapping young man sitting in my living room. And my wife came around the corner and said, "Stephen, I want you to meet Marcus." Marcus is thinking about pollution in the ocean. Turns out he came back from a tour in the Middle East as one of the elite soldiers and probably had some makings of PTSD, but rather than go downhill, he aspired for higher things, went to college, got his PhD in ocean sciences, and decided to dedicate his life to working on cleaning up the oceans. And what was he going to do for his premier event? But to build a raft and sail through the Pacific Gyre on a raft. And the raft, I'm not making any of this up, the raft was to be floating on pontoons of soda bottles. Yeah, and he built it with a salvage fuselage for when the waves come over the raft and a bunch of aluminum, basically salvaged sailboat masts. The first time I went to see him, I asked about the screw caps on the bottles. Did you glue those? No. Well, you've got the wave action that does this, and those screw caps are going to get loose. You really have to glue them. I think they'll be all right. Take it out on the first little trial run, they dragged it out in the harbor, and all of a sudden, on the way back, it started to get a little closer to the water. And they had to take them all apart and glue the caps. I mean, this is just nuts. First of all, sailing west from California into the Pacific, the trade winds are coming from the west to the east. They have no propulsion other than to go, yeah, I know, it's just batshit crazy. And so my wife says, and by the way, we're going to design and install his life support system. The electricity for the radio phone, the satellite phone, the radar, because, hey, you're crossing shipping lanes and you're going through where the cargo container ships and the tankers are coming through the shipping lane at night. Yeah. And we were going to be responsible. I took my wife aside and I said, have you seen our insurance? That malpractice is not going to cover this. She said, we've got to do it. So here they are. Yeah. Two of them. Both from duty in the Middle East. Going to make a difference. The story gets a twist, though. Of course, something like this and so dramatic, there has to be a femme fatale. This is no ordinary lady. She aced Oxford University, immediately got into a fast-track career. 10 years in, basically, he looked in the mirror and said, this isn't doing it for me. The same kind of thing that Marcus had. And became an environmental activist. There she is. She was also the captain of the Oxford rowing team. That's men and women. She was the captain of the rowing team. She knew how to row, as well as acing through Oxford. And she decided she was going to row single-handedly across the Atlantic. And she did it. And she even ill-timed and got into some hurricane stuff coming into wherever she landed, in the Caribbean somewhere. But, yeah, I'm not making any of this up. So the relevance to this story is that after doing the Atlantic, she decided she was going to do the Pacific. And so Marcus left on the raft from Los Angeles. She left in her rowing boat from San Francisco. And they both had satellite phone communications. Her water distillation unit failed. She had no drinking water. And the folks on the raft had been blown way to the south and somehow recovered. And guess what? They ran out of food. She had extra food. They had more water. They managed to meet in the middle of the Pacific. I mean, this gal is serious. here she is landing in Hawaii for the press conference. Anyway, they met, tied up, and the guys went snorkeling and got a few fish, and they had a dinner together. Her water supply was replenished. They got some of her extra food. They both headed on into Hawaii, and here's her landfall. Fortunately, the system did not fail. We had batteries on board that were salt water. You know, the solar modules were getting, it was, yeah, never again, never again. The Lord's house has a dual mode system. It has solar array, a bank of batteries, and an inverter that is capable of working with the utility or without the utility. The battery system supports the solar input. When the utility fails, there is a disconnect, which is not shown here because of simplicity, and a backup panel. We call that a critical loads panel. You can power your whole house, but heaven's sakes, if you have a power outage, do you have to run the clothes dryer? No. Do you have to use all of the things in the oven? No. You can if you want, but you don't have to. So we usually have a backup or critical loads panel. That is what's powered when the utility fails. And interestingly enough, the owners don't know there's a utility outage until the neighbors are knocking on the door saying, can we come in? Have some tea maybe? The challenges with this project was the mortgage financing. This is the roof integration, of course, that we mentioned. The solar modules, both thermal and electric, make up the finished weathering skin of the structure. In this case, the mortgage authorities wanted to see the plans. That was the beginning of the trouble. Well, what's this? What's that? How are you doing this? How do you know it's going to be watertight? What about insurance? It's like, can you get another mortgage? Maybe somebody else? Finally, they got a mortgage. It was interesting. How many of these have you done in Maine? None. How many are there in Maine? None. Yeah. Mortgage people can be really curmudgeons. And that's what they do, you know. So contractor selection, permitting. Yeah, the carpenter that didn't do very well in his trades, and the uncle was an alderman, and he became the building inspector of this small town. And you're going to do what? Those are electric modules, are going to be the roof, the weathering roof. Yeah, so you can imagine the fun was there. And then contractor selection, of course. We had to install the solar system. There's the owners, very happy. The house is wonderfully daylit, lots of passive gain, and they're still at it. This is 25 years later, or more, I think. So, upstate New York, a very exclusive family retreat compound in the Adirondacks. They have 800 acres, including 2 lakes. And the best place to put the solar was on the boathouse because there is no electric grid for them. This is summer cabins principally, and a full kitchen, of course, and a central meeting house and that sort of thing. Not trivial loads. They had generators, of course, but they wanted to go solar, so now we have a generator hybrid system with battery bank and transfer switch and inverter and multiple loads across the property. This is a typical view of battery stacks. Batteries are now stacked vertically. The stacks are roughly the footprint of a large residential refrigerator. The electrical conductors are down the face. There's a plastic guard to keep the little kids from playing with them in the basement, maybe. We were privileged to do an ecotourism resort on a barrier island off the coast of Belize. We designed a custom torque tube structure where you've got modules balanced along a center torque tube, which can be adjusted with just one hand because it's perfectly balanced. Can anybody tell me why we did that? There are two reasons, one really important and one just good. What did I hear? Yes, hurricanes. We can design for the wind loads, but we can't design for the wind-driven debris. And so you tilt, you got a couple of days of notice. You tilt the array horizontal. You got 2 inches of aluminum as opposed to a billboard of tempered glass. But also it allows them to do a summer tilt and a winter tilt. Adjust in the spring, adjust in the fall. You get about a 25% boost. Same concept here, although they had multiple generators on site. They have AC distribution across the property, a fairly large battery storage. These are, maybe 6 feet tall and weigh 1,200 pounds, 2-volt cells. And when you go into the battery room, your hair stands up and it's going zzz to run the whole place. A house in northern New England, as we were designing houses in the early days, and I truly enjoy it, but it got to be wearing. First of all, I'm really a solar guy, and so I want to get as much solar out there as possible. And without being pejorative in any manner, spending 3 months helping the Joneses pick out their bath tile was just not doing it for me. And so what we decided to do was work with other architects and help them design better buildings because they were used to doing this stuff. And you find the right match and it's perfect. These folks wanted a 21st century farmstead with traditional design that was energy positive. The solar went on the out barn where the animals go. The solar electricity, again, roof integrated. The solar thermal is on the barn garage, which the top tier is a studio space. And they have his and hers EV chargers and our net zero. Here's some of the electronics, more of the batteries that you've seen. Another shot of the house under construction.